Okay, we're going to talk about some two-step equations now, and we're going to use a method called backtracking. And what that means is we're going to think about everything that's happening to our variable. So the first thing happening to our variable here is it's being multiplied by 6. So first, x is being multiplied by 6. Okay, x is being multiplied by 6. The second thing happening to now it's 6x to this x. First I multiply, then I'm subtracting by 9. Okay, and that will give me 33. So x is multiplied by 6 and then subtract by 9. I need to undo these things, and I'm going to work my way up. I'm going to backtrack back to x. Okay, so I'm subtracting 9. My inverse operation is going to be to add 9. And now I'm multiplying. When I multiply by 6, my inverse is going to be to divide by 6. Okay, so that's what I'm going to do. I'm going to undo this subtraction with addition. I like to keep it lined up here. What I do to one side, I do to the other. These cancel each other out. Minus 9 plus 9 is 0. So this is 6x equals whatever's on this side now. So 33 plus 9 is 42. Okay, and then now I'm back to 6x, and this is just a one-step equation. 6 times what number is 42? I can use my inverse operations. Again, if I'm multiplying by 6, I divide by 6. That is my inverse, is to divide by 6. So I'm going to divide, again, both sides by 6. The purpose in doing that is to clear that out. 6x divided by 6 is just x. And 42 divided by 6, well, that simplifies to 7. Now, again, I like to check my work, so I'm going to do that. If you're telling me x is 7, I'm going to put it into my equation and see if it's a true statement. Okay? 6 times 7 is 42. 42 minus 9 is 33. That's a true statement. X is 7. All right, let's keep going, but we're going to amp the difficulty up because now I have a fraction. All right? Again, I'm going to backtrack. First thing happening to x is it's being multiplied by 3/7. Okay, and then the second thing is I'm adding 12. So when I work my way up, I work my way up with inverse operations. I'm undoing this addition with the inverse is subtract 12. Okay, and the inverse of multiplying by 3/7 is to divide by 3/7. So that might be a little bit difficult for us if we struggle with that. All right, so I'm going to subtract 12. Why am I going to subtract 12? Because I want to start to isolate this variable. In order of operations, I would do this first, this multiplication first, then my addition. So I'm going to undo them in reverse order here. So I'm going to subtract 12. Again, I like to keep it nice and pretty lined up here. Plus 12 minus 12 leaves me 0. So this is just 3/7 x. All right. 18 minus 12 is 6. All right. Now I'm multiplying 3/7 and x. So I need to divide. I need to inverse operations that. So I'm going to divide this whole thing by 3/7. I'm going to divide this side by 3/7. Now, again, this is where it gets a little sticky, but this left side, a fraction divided by a fraction, oh, that's rough. But if I'm dividing a number by itself, just like before, that goes away. Just like my 6x divided by 6, that goes away. It turns into 1. 3/7 x divided by 3/7, that goes away. It turns into just 1. I'm left with x on this side and a division problem over here. 6 divided by 3/7. All right, again, not too bad. Let me slide this up a little bit. Not too bad. When I divide by a fraction, I multiply by its reciprocal. So this is 6 over 1. 6 and 6 over 1 are the same. I multiply by its reciprocal. So I'm going to multiply by 7 over 3. I flip that second fraction over. I multiply across, because that's what I do when I multiply fractions. 6 times 7 is 42. 1 times 3 is 3. This simplifies 42 divided by 3 to 14. Now, I know I'm correct because I'm going to prove it. So let me try to find a little hole over here. This, I can put 14 back in and it'll work. Let's double check to make sure though. 3/7 times 14 over 1 plus 12 should give me 18. Well, 3 times 14, we just did that, was 42 over 7. That's 6. Okay, so this, oh, you didn't see that. 3 times 14 is 42. 7 times 1 is 7. 42 divided by 7 is 6. So this box right here, these things equal 6. So this is 6 plus 12 equals 18. That's a true statement. Yes. So I know x must be 14. X equals 14. All right. Last one. Last one's the best one. Okay. I have 12x plus 4 plus 9 equals 95. Now, I can subtract each one of these separately, or I can combine them together and do that. That's what I'm going to do. I'm going to combine this 4 and this 9 together, and I'll have 12x plus 13 equals 95. Now I'm going to use my backtracking. Again, first thing that's happening to x is multiply by 12. That's what's the first thing happening to x right here, 12x. And then I'm adding 13 is the second thing happening to x. So I'm adding 13. Now again, I want to work my way backwards, so I'm going to undo each one of these things. I'm going to subtract 13. That's the inverse operation of adding. And I'm going to divide by 12 because that's the inverse operation of multiplying by 12. All right, so let's do that. Subtract 13 from both sides. I want to get rid of this 13. That goes away. I do it on this side as well. This is now 12x equals, 82. Okay. All right. I'm going to divide this by 12. Divide by 12. This is not going to give me a pretty number. It's not going to come out nice and even. It's going to give me a fraction. This goes away. X is equal to 82 divided by 12, which I can simplify. 2 goes into both of these, and that's pretty much it. Okay, so I can drop this down into 41 over 6. That's it. That's what that's going to be. And I can put that back in and substitute it back in. I like to put it back in my original equation just to make sure I'm correct. Okay, so when I do that, 12 times 41 is going to give me a large number. It's going to give me actually a pretty large number. It's 492 over 6. 492 divided by 6 is 82. Plus 4 plus 9 is 95. That's a true statement. 82 plus 13 is 95. Where did 82 come from? 12 times 41 is 492. 1 times 6 is 6. I can simplify 492 over 6 into 82. Plus 4 plus 9 is 95. All right, what are you going to do? You're going to try the other 3 that are on the back of this, and you're going to enter those into Schoology.